In this video, we are going to talk about zeros of polynomials. So a zero of a polynomial, a number is called a zero, also called a root or solution of a function p of x if p of r is equal to zero. So some people are confused by that terminology. They just think about the number zero itself, but that's not really what it's talking about. When we say a zero of a function, we're talking about a number such that when we plug it into the function, we get zero. Okay, so the example here is that 4 is a zero of the polynomial p of x equals x squared minus 16. The reason why, right, is, or how you check, right, is just to plug 4 in and see what you get. So if I plug a 4 in, I get 4 squared minus 16. That's 16 minus 16, and that's equal to 0, right? So we would say 4 is a 0 of p of x, okay? All right, because when we plug it in, we get 0. Okay, and so a big part of what you would want to do with polynomials, and historically a big problem, is to find all of the zeros of the polynomial. So we've been doing this kind of all along, just really haven't phrased it in these terms. We've solved linear equations, right? And we've solved quadratics using the quadratic equation, right? And so those are the way that you would find the zeros of a linear function or a quadratic function. So basically, to find the zero of a polynomial, you're really just going to try to solve, set it equal to 0, and then solve that out, okay? That's a fairly difficult problem, okay? And in general, and it's a large part of what people were trying to do in algebra for a lot of years. Until about in the 1800s, they figured out the situation to a fairly good extent. So what we're going to do is stick with polynomials that can be factored fairly easily, and so that's how we're going to go about finding zeros of polynomials. We're not going to talk too much about the really difficult problems, although a tiny bit we will. So, all right. So once the polynomial is factored, right, then all you would do is set each factor equal to 0 using that principle of zero products that we talked about in class. So, okay. Let's see here. So our first example is going to be x squared, or x to the 7th minus 4x to the 5th. All right, so I'm going to have to set up my that's not what I want. There we go. That's what I want. All right, so let's go back to the problem. So the problem is p of x equals x to the 7th minus 4x to the 5th. All right, and that is too small to see, so let me make that bigger. Okay, so what we would do to find the zeros of this polynomial is set it equal to 0, and solve that out. Okay, so looking at this polynomial, I want to try and factor it, and the first step in factoring is always to factor out the greatest common factor. So we can see that this has two terms, and those two terms have x's in common, right? They all have at least 5 x's. And so that's what we're going to do, is to factor out x to the 5th power. All right, so when I factor x to the 5th power out of x to the 7th, what I will get is x squared. And when I factor it out of 4x to the fifth, I will get x squared minus 4. Okay, so now I can factor that a little bit more. It's the difference of two squares. So I'm going to go ahead and do that. All right, x squared minus 4 factors down to x minus 2 times x plus 2 equals 0. Okay. And so now I basically have the left side completely factored. And you might notice, this is sort of the factored form of that polynomial up here. Okay, and so now I've got three things that are being multiplied. X to the fifth times x minus 2 times x plus 2, and I get 0. So if I multiply a bunch of numbers together and I get 0, that means that at least one of those numbers had to be 0. So either x to the fifth was 0, x minus 2 is 0, or x plus 2 is equal to 0. Okay, and now I can solve each of those. Over here, if I just add 2 to both sides, I get x equals 2. Here, if I subtract 2 from both sides, I get 0. On the x to the fifth equals 0, right, then really the only solution to that is x equals 0. The reason being is that if I take any number, right, and raise it to the fifth power, if the number I raise to the fifth power is positive, then I'll get a positive number. So that means that x couldn't be positive here, right? If I take a negative number and raise it to the fifth power, I will wind up with a negative number. So it couldn't be 0. But 0 to the fifth power is certainly 0, right? That means the only solution, the only number that I could raise to the fifth power and get 0 is 0 itself, okay? Another way to think about that is you can take the fifth root of 0 of both sides and you'll get x equals 0. But I kind of prefer the way I just mentioned to you previously. If I have any number raised to the fifth power and it comes out to be 0, well, there's only one number for which that is true, and that's 0, right? So these are the zeros, right, of the polynomial, okay? All right. Right, the next example, I want to find the zeros of x cubed minus 3x squared minus 9x plus 27. Okay, so let me write that down. Actually, not at the top there. All right, so p of x equals x cubed minus 3x squared minus 9x plus 27. All right, so I want to find the zeros of this polynomial, so I would set the polynomial equal to 0 and solve that equation. All right, so this equation has 4 terms, 1, 2, 3, 4. And what I need to do, if it has 4 terms, we want to try factoring by grouping. So in other words, I want to look at these two and see what they have in common. They have an x squared in common, okay? And so I would factor out the x squared, and I would get x minus 3 when I do that, right? If I pull the x squared out of here, I'll be left with just 1x. If I pull the x squared out of here, I'll be left with the negative 3. All right, then next up is I want to look at these two, right? And I want to pull out what they have in common, which is a 9, right? 9 goes into itself once, and 9 goes into 27 3 times. The issue, though, is whatever I pull out of these, I want what's left inside the parentheses to exactly match this term right here, okay? So instead of pulling out a 9, I'm going to pull out a negative 9. The reason being is that because, so the signs work out that they're exactly the same as this term right here. So negative 9x, and I factor out a negative 9, I'll get a positive x. And then the plus 27, if I factor out a negative 9, I will get a minus 3. And that works out because these two terms are exactly the same, and that's what I need with factoring by grouping. Okay. The reason I need that is because now I essentially have two big terms with something in common. So I'm going to pull out what they have in common, which is that x minus 3. And if I pull the x minus 3 out of here, I'm left with x squared. If I pull an x minus 3 out of here, I'm left with that minus 9. Okay, and so I've got it factored now. The thing is, I can factor this a little bit more, right? This x squared minus 9 is also the difference of two squares, so I can write it as x minus 3 times x plus 3. Okay. And so now I have it completely factored, right? And you can set each of these factors equal to 0 and solve those out. So either x minus 3 is 0 or x plus 3 is equal to 0. Now, some people ask at this point, well, do I need to set both of these x minus 3's equal to 0? And the answer is no, not really, because you'll just get the same solution, right, which is x equals 3 here. But something that we will talk about later will make the fact that there's two x minus 3's important, and that's what's called the multiplicity of a 0. And the multiplicity of the 0 is basically how many times that factor that you got the answer from appears in the factored form when it's completely factored. So here later on we'll talk about this and say that 3 is a 0 of multiplicity 2, whereas with this other factor, x equals minus 3, this is a 0 of multiplicity 1, because in the factored form, the x plus 3 only appears in there one time. Okay, but that's for another video. All right, so right now we're just finding zeros, and that's our answer on this one. All right, let's take a look at the next example. All right, the next example is p of x equals x to the 4th minus 17x squared plus 16. All right, and so we want to try and factor this. First off, right, we want to find the zeros, right? So we would set it equal to 0 and try and solve that out. So we hadn't really talked about how to factor something that has x to the 4th, and for good reason, because that was really complicated. But this is kind of a special one that's easier to factor if you've done factoring before. The reason why it's easier is because you can see that it has 3 terms. This is x to the 4th, and then this power is exactly half of this one, right? That helps to be able to factor it, because what you can do, I'm just going to kind of move over here to the side. You can factor this just like you would factor x squared minus 17x plus 16 equals 0. So that's one that we have encountered before, right? Or how to factor that. we would need two numbers that multiply together to give us positive 16, but add up to give us negative 17. And so those two numbers would be minus 1 and minus 16. Right, just checking. Negative 1 times negative 16 is positive 16. Negative 1 plus negative 16 is negative 17. Okay. So then because the leading coefficient here is a 1, all we have to do is put those numbers in. Remember, that only works if the leading coefficient of the quadratic is 1, right? If there's anything else besides 1 with the x squared, then that's out the window. So if it's like this, x squared minus 17x plus 16, we know how to factor that with no problems, right? So notice, though, that these two basically follow that same pattern, right? Here, the coefficient is x to the fourth, and on the middle one, it's x, or the exponent is x to the fourth. The exponent on the middle term is a 2, which is half of this one. This is the same thing, right? Because this is like having a 1 right here. So it follows that same pattern. This middle term has an exponent that's exactly half of this, right? And the constant term there. So what that means is that this polynomial over here is going to factor almost exactly the same way, except instead of being x minus 1 and x minus 16, it's going to be x squared minus 1 times x squared minus 16 equals 0. Okay? So you might say, hey, well, how do I know what should go here? And it's this term right here, right? So you can see on the usual example that we do, it's x minus 1, x minus 16. On this one, it's going to be x squared minus 1, x squared minus 16. So you can factor, a lot of stuff like that, a lot of higher degree polynomials if they follow that format. If they don't, then that's a totally different story, and that's way more complicated than what we'll go into. So, all right, we still want to make sure to factor completely, right? So both of these are perfect squares again, our difference of two squares rather, not perfect squares. So both of these can be factored. X squared minus 1 factors to x minus 1, x plus 1. X squared minus 16 factors to x minus 4 times x plus 4 equals 0. Okay? And so now we have this polynomial completely factored. So we would set each factor equal to 0. And then solve each of those. So here we get x equals 1. Here we get x equals minus 1. Here we'd get x equals 4. And here we get x equals negative 4. All right, so those would be the zeros of this polynomial. 1, negative 1, 4, negative 4. All right, I think that's the last example in this video. And in the next video, we'll talk about multiplicities of zeros.